The wheel of a small gyroscope is set spinning by pulling on a string wound around the shaft. Its moment of inertia I is equal to double 5. So I is equal to double 562.5 kg mm square. So it is mass moment of inertia. Why? Because product of mass and square of the perpendicular distance. And the diameter of the shaft on which the string is wound is 12.5 mm. So diameter is given as 12.5 mm. If 750 mm of the string is pulled off, the length of the string pulled is 750 mm. Let us denote with L. With a constant force of 53.4 newtons and force value is also given 53.4 newtons. What angular velocity will be imparted to the wheel? Angular velocity omega you need to calculate. So here figure of the problem is not given, so you need to draw the figure. So let us consider this is the wheel. So to the wheel there is a shaft. So in 3 dimension it will be like this. So there is a wheel like this. To the wheel, so there is a shaft like this. So to this shaft, so there is a rope wound around that. So here we are applying force F on this, so then it is able to rotate. So this is wheel and this is shaft. Here this is the shaft. So to this shaft we have applied a force of F, so which is 53.4 newtons, that is given in the problem. So for any problem, first you need to find the acceleration. Here if you observe, it is a rotational motion problem, so angular motion problem. So here you need to find angular acceleration. First convert the units. So here it is given as 5562.5 kg mm square. Convert this one into kg meter square. How to convert means 1 meter is equal to 10 cube millimeters, right? So from that 1 mm is equal to 10 power minus 3 meters. From that I is equal to 5562.5 kg mm square. Here is the unit. So mm square can be converted into 10 power minus 6 m square, right? So into 10 power minus 6 kg meter square. And here diameter is in terms of millimeters. Convert this one into meters. 12.5 into 10 power minus 3 meters. Here also 750 into 10 power minus 3 meters. So it's okay. So now, so the relation is for rotary motion problems, m is equal to I alpha. So likewise for for linear problems, linear motion problems, we use F is equal to ma. Likewise m is equal to I alpha is the relation for angular motion problems, where m is the moment of force and I is the mass moment of inertia and alpha is angular acceleration. So here moment of force is nothing but product of force and perpendicular distance, right? So F is the force. So perpendicular distance up to the center is nothing but, here it is radius, right? So F into R is equal to I alpha. So here force is given as 53.4 newtons into radius is 12.5 into 10 power minus 3 divided by 2. 12.5 is the diameter, so divided by 2 will be the radius, is equal to mass moment of inertia is given as 5562.5 and we have converted that one into kg meter square, so into 10 power minus 6 into alpha. From this relation you need to find alpha, calculate that. So when you calculate it you will get 60 radians per second square is the unit for angular acceleration. So now we got angular acceleration. And here the linear displacement is given. So we need to find the angular displacement. So parameters should be in angular motion, right? So we know that L is equal to R theta. So length of the string is equal to radius into angular displacement. So length of the string displaced is nothing but 750 mm, right? In terms of meters, 750 into 10 power minus 3, and radius is 12.5 into 10 power minus 3 divided by 2 into theta. From that I can find the value of theta. So 10 power minus 3, 10 power minus 3 gets cancelled. So 750 into 2 divided by 12.5. So when I solve that, I will get 120 radians. So now I got theta and I got alpha. So which relation I need to use? I need to find angular velocity. So initially this is at the state of rest. When I apply force only, this is able to rotate. That means initial angular velocity omega naught is 0, right? So omega naught is 0 and alpha is 60 radians per second square we got, and theta is 120 radians we got. So from these parameters, and we need to find omega. So from these parameters I can select the equation omega square minus omega naught square is equal to 2 alpha theta. Omega square minus initial angular velocity is 0. 0 square is equal to 2 into alpha is 60, theta is 120. From that omega square is equal to 120 square, right? 2 into 60, 120, 120 into 120, 120 square. From that omega is equal to 120 radians per second. So this is the final answer. Hope you like this video. If you like this video, click on like button, and for more videos do subscribe my channel. Thank you for watching.